Thanks everybody for joining us. Really excited about this topic. Again, my name is Jacob Steiner. I'm actually a co-founder and one of the managing directors for Smart Energy 360. And we are a licensed broker and aggregator and provide national services. We also do energy project development, energy efficiency, whether it's lighting or insulation and especially solar development, commercial solar development. So really happy to be here. So if you want to jump into the slides, we'll just kick this off and go through it. So this is a topic, Texas electricity system optimized for efficiency, not resiliency, and how we can better prepare for our future. If you go to the next slide, here's the main objectives that we're looking to accomplish. This was on the session outline. And if you go to the next slide, we're just going to jump right into it here. So for those of you that are new or aren't as familiar with the district, this is a little bit about the district, and I highlighted a section there at the end that this session is directly targeting, that one of the overwhelming objectives of the district is to keep properties and businesses competitive while operating buildings more efficiently, thereby reducing the costs and the environmental impacts of building operations. And so this topic is directly related to that mission of the district. And the district was founded, gosh, Salima, what's it been? 5 years now? 6 years?
So late 2014. So yeah, it's wow. Been 7 years.
Yeah, 7 years. So if you go to the next slide, in case you missed it, this happened about a month and a half ago, February 14th through the 19th. We experienced a rare storm event that froze up the whole state and other parts. So if you go to the next slide, what did that have to do with the electricity system? Well, there certainly was no shortage of headlines. I pulled a few out here, and a lot of finger pointing, a lot of it's their fault, it's this person's fault or this group's fault. And so I just pulled a few out here that jumped out. And if you'll go to the next slide, this is not a presentation about who's to blame. This is a presentation about what we can do about it. This is a discussion about, gosh, what's in our control and what's out of our control. And one of the things that's out of our control is the grid. This is managed by ERCOT. So this was a headline that really jumped out about how close we came to grid failure. And when an electric grid fails, it's not like your house where you just go flip the breaker back on. The entire grid comes down, and there's a sequencing process to bring it back up. So we were very close to that failure, and could have potentially been without power for weeks. If you go to the next slide, the financial disaster really came into focus when I came across this figure from the Independent Market Monitor, which is an organization called Potomac Economics. And they monitor Texas power grid, and they report back to the legislature. If you look at the last underline there, $10 billion in real-time market costs for all of 2020. And in the February 14th through the 19th, the grid totaled $47 billion. So almost a 5x increase in 4 days. This wasn't sort of a small event. This was an exponential disaster. The full effects are still not known. If you go to the next slide. This was my personal favorite. I don't know Ed, but I thought that he said it quite frankly. And the electricity market did fail. And in the words of ERCOT, it functions just as designed. I would agree with that in some different ways that we'll talk about. ERCOT has congratulated itself for only losing 40% of the grid and is proceeding to handle transactions to transfer more than $50 billion for consumers to electricity generators. There will be an investigation, and we have some updates on that. But I thought that he kind of hit the nail on the head. Was this incompetence or dishonesty? When this $50 billion that the generators are now charging to consumers, how did that happen? What needs to be done about that? What can we do to prepare to protect against that? If you came early, you heard us talking a little bit about what our electric bills were personally. I hope that nobody got personally impacted directly, but very likely somebody did. If you go to the next slide, Let me go through some boring background here for you on who ERCOT is, if you'll hit the button there for me. ERCOT is the Electric Reliability Council of Texas. And the reason we're starting here is they got a lot of press and you see their name a lot. And I think it's important to understand what their role is from their public presentations. And so this is directly out of their slides. But they have 4 main responsibilities required by law as the independent organization certified by the PUC, the Public Utility Commission. Public Utility Commission is the same organization that licenses our brokerage and aggregations. So for ERCOT, they maintain the system reliability. They facilitate the wholesale market. They ensure open access to transmission. That's the service lines. And then they facilitate a competitive retail market. So you'll see there, they do both the wholesale market and the retail market. They're facilitators there. Some things they don't do. ERCOT does not own or operate or have any enforcement authority over generation facilities. It's important to know that they don't have control over them. They're a reporting agency. They facilitate the reliability of the market, but they don't have control. So they don't sell or send bills for electric. They don't operate service, and they don't establish any of the pricing or the rates. They do not have any direct customer relationships with the public. So I think it's important to have a little understanding about who ERCOT actually is and what their role is. If you go to the next slide for me. Here's an overview of our electric grid here in Texas. The generation, transmission, distribution overview that ERCOT's responsible for. You'll see there the highlighted sections. That's what our percentage of generation for each of those assets is. So about half of all the generation in Texas comes from natural gas, and you'll see shortly why that's an important thing to know. Solar about almost 6%, and wind about 30% of our power now comes from wind. And much of that has been from the growth of the market. And then about 5% from nuclear. If you'll go to the next slide there. The amount of generation, which are the generators that are producing electricity to be sold on the wholesale market. If you see there on February 14th, we began with about 25,000 megawatts of power that was out. And at the peak, we had about 50% of all of our generation capacity in the state of Texas was down. That's a huge number. If you go to the next slide, what that means is you can see there's a rapid decrease in generation, which causes a frequency drop. So if we've got any electrical engineers on here, you'll be much more knowledgeable about this than I, but I can read the slide. And what it basically says is that once the hertz drops below 59. That's what the little highlighted section there. If we would have dropped below that line, the frequency would have tripped all the equipment that's attached to the grid. By trip, that's a general word I'm using. I don't know that that's the technical word, but it would have brought the grid out of balance. And so that's what they're referencing when they say we were almost more generation units would have tripped if below 59.4 for 9 minutes or more. So that's where that 5 minutes from failure came from. If you go to the next slide for us. The questions going forward for everybody are what kind of procedures will we put in place and what's going to be done about it next time? But more importantly, how much is that going to cost? Bruce Bullock's a friend of mine. I'm actually on the associate board of the McGuire Energy Institute at SMU. We've got some SMU alums on here. And really, the question is how much insurance are you really going to take out for something that's not likely to occur? This is very much a discussion. My portion of this discussion is really about risk management. And from a commercial real estate perspective or a critical facility perspective, it's important to understand the risks that are built into the system so that you can properly hedge against those risks, both on paper and in the physical building. So one point to mention here is that this happened 10 years ago. The recommendations that came out of the catastrophe 10 years ago were not implemented. There's some discussion in the state legislature right now about another report that's going to be published, and some of the politicians have pointed out that, well, we already did this report. We did it in 2011. It's the same thing. Nothing was done about it last time, and here we are going through it again. But you can see on the slide to the right there the magnitude of how much more this was, how the exponentially greater here. You know, we were Maximum generation capacity forced out at any given time. In 2011, 10 years ago, it was about 14,000 megawatt hours. This time it was 52,000 megawatt hours. Again, half of our generation fleet. If you go to the next slide, this is Potomac Economics. This is, again, the independent market monitor. I've highlighted some of the key points in there. This was what they published March 1st, 2021. It was their recommendations to the made to the Public Utility Commission of Texas. Okay, and you'll see right there the following recommendations are related to ancillary services. They had two recommendations, and we'll talk about what ancillary services are. But they recommended capping the ancillary services clearing prices at a system-wide offer of $9,000 a megawatt hour. Most bills aren't in megawatt hours, and most bills are in kilowatt hours. That would be $9 a kilowatt hour. So if your contract per se is for 4 or 5 cents in per kilowatt hour, that would be $9 per kilowatt hour. And then recommendation 2 was to invoke a failure to provide settlement, basically saying that if you didn't provide power, you shouldn't be settling these bills with customers that weren't getting the power. And so if you go to the next slide, what actually happened? Well, Texas regulators declined to act after the market monitor reports $16 billion of inappropriate ERCOT charges. They declined to reverse the grid operators' inappropriate pricing. That $16 billion, the way they get to that number is if you capped it at $9,000 per megawatt hour, that would have reduced that $50 billion by about by a fair amount. And so then you would only be $16 billion over what it should have been. But instead they didn't, and they're allowing those charges to stand. And they said that these are difficult decisions as felt it was dangerous to redo pricing retroactively. You don't know who you're hurting, and so you think you're protecting the consumer. It turns out you're bankrupting a co-op or a city. So it's very complicated. It's not as easy as just, well, let's just republish everybody's bills. So where does this leave us? Right where we were before it all started, no different. And so to say that the grid performed as it was designed is a true statement, in my limited opinion, that it did happen the way it was designed. But we didn't ever imagine that there would be this perfect storm of generation being out, natural gas being frozen. So if you go to the next slide, what can we do about it? So here's ancillary services. If you're not familiar with ancillary services, this is a little bit about that, but I'll go into a bit more detail about what they are if you've never heard them, but the formula was used to calculate ancillary services generated answers in the 20,000s. So what they're saying there is that the cap was supposed to be 9,000 megawatt hours, but what they actually saw were ancillary services being generated and priced at $20,000 a megawatt hour. That's $20 per kilowatt hour, every single kilowatt hour, $20. So if you go to the next slide, what are ancillary services? One more for me. This is a really simple diagram and so fascinating. I probably should have a poster of it in my background here instead of mountains. But if you see the little blue box number 6 where it says demand, top left, this is a representation of the North American electricity market diagram, but it's applicable to the Texas ERCOT market because we are effectively our own grid. And so demand or load comes out in 2 ways: net energy, so that's the actual energy commodity that you're consuming, the electrons, and then there's ancillary services. And so what's really in dispute are those ancillary services. The net energy load was capped at $9,000 a megawatt hour, so that part did cap out, but the ancillary services were not. So if you go to the next slide, ancillary what? These are service costs that ensure the reliability of the electric grid. There are 4 principal ISO, and that stands for Independent System Operator-wide ancillaries, and there's 4 of them. I didn't go too in detail here, but the regulation upcharge, a responsive reserve charge, a regulation downcharge, and then the non-spending reserves. So ancillary services are deregulated, and they're considered part of the generation or energy portion of your electric bill. Probably you've never seen this line item on your bill because it's buried in the energy rate. So the graph to the right is a graphic representation of what percentage of the bill ancillary services make up, of your energy costs. So it's really only about 7% of your energy cost. And you can see the volatility as well. If you go to the next slide, this is how the average price per kilowatt hour is calculated. It's a similar graphic here, but the average price on your electric bill is composed of two separate costs. The first part is the most important part. It's the delivery cost. This is the regulated portion of your bill. You can see the Encore logo there. It actually says in their logo, we deliver. That's what they do. They deliver power from the generator to the consumer, and that's all they do. They are regulated and controlled by the Public Utility Commission. You don't have a choice. Now, where you do have a choice is in the commodity, the deregulated portion of your electric bill. That's a market-based rate, and it's determined by the generation companies and the retail electric providers. This is where you have a choice. So if you go to the next slide there, this is a sort of standard electric bill. There's lots of different forms and formatting, no standard format, but this one's pretty easy to read. And there's, again, two parts to your bill. The first part there is the demand and delivery in the red, and that's the part that you can't change. And then there's the generation. Now, typically in Texas, most people are on fixed price contracts. If you're not, you probably found out the hard way in this last freeze of the difference between an index rate and a fixed rate. Fixed rates are intended to remain fixed no matter what happens. And now there's contractual terms behind that, but we'll get into that. So typically you don't see ancillary charges line itemed out because they're buried in that energy rate. So where it says 547764 at 4.049 cents per kilowatt hour. Okay, so if you go to the next slide for me there. This is a couple excerpts from energy contracts. And so this is where we'll kind of get a little technical in managing this risk, okay? A lot of folks, when you go out to buy power, it's, well, what's the rate? And then you typically will evaluate based on the pricing. But what doesn't really get brought into the conversation until we have these disasters, these grid disasters, like does happen in 2005 with Hurricane Katrina, 2008 and 9 when natural gas prices shot up to $14 an MMBTU. Again in 2011 when we had a massive freeze, and then recently in 2021, February, when the whole market shut down. So the contract price for electricity consumed in a billing cycle price may include, and you'll see right there, all non-utility charges, including energy, ancillary services, and then congestion losses, unaccounted for energy, and then other ERCOT and ISO charges. So these are all rolled into your energy rate. And then you'll see it's another, the box at the bottom there, bundled charges and pass-through charges. This is a different contract form, but again, where they bullet out, it's important to look at your contract and see what's actually included. There are some providers, and you can choose electric products that pass through ancillary services. If it was an index price, all of these would be pass-through charges, and you would pay a retailer margin. So what's important to note is that ancillary services, whether you know it or not, you're buying them and you're paying for them. The question is, did your retailer hedge them appropriately? So if you go to the next slide, this is just a simple graph to give a sense of how many different charges are actually in your energy rate. Most of the rate should be energy, the actual electron that is used to light the lights and drive the motors. But if you see down there at the bottom, ancillary services and ISO costs, they're typically a very small percentage of the total. But there's a lot of other charges that are built into that energy cost. If you go to the next slide, this was another headline that jumped out. And I like to ask the question of what do you think? I don't want to tell people what to think here because it really, your perspective matters on this. I'll share mine because I'm speaking, but it's important to know that everybody has their own conclusion on what do you think? Do you think that we do save money or we don't? So here's a couple facts and figures that we present. If you go to the next slide, when we talk about Texas, my company, Smart Energy, is a national firm. So we do work right now. One of our primary clients is based out of New York, and they're a large REIT. They own properties all over the country. So I personally worked in Chicago and New York and all over Texas and California and Hawaii. And so I feel fairly conscious to what goes on in Texas. And so this is what we present when we talk about the Texas grid. So you've got deregulation. It's a restructured electric market, much like ComEd in Illinois or NISO in New York. And what happens on the left is you got power generation companies. Okay, that's like Exelon, Luminant, NRG. There's your transmission distribution provider, Encore, they deliver. And then there's the retailers. The retailers buy generation and delivery, and then they publish a bill with the appropriate rates, and they send that to the end user. So the retailer is responsible for all the interaction with the end customer. And there's many of them. If you'll notice, many of the logos actually match. So Constellation and Exelon have the same logo. Reliant and NRG have a similar logo. It's because the generators own those retailers, but retailers by law are not allowed to own generation. So if you go to the next slide, Samantha. This is a slide that we often present on national presentations that we do. And this is from the Energy Information Administration. And Texas is the green line on the far right at the bottom. And a lot of times when stuff like this happens, we have folks from other states commenting on our grid and how, well, it's not reliable and they should do things the way we do it in our state, particularly California is often used. We do work in California, and I've done a lot of rate analysis out there, and the peak rates in California can get as high as 25 cents a kilowatt hour. We don't have that problem in Texas unless you're on an index rate. Texas is very, very inexpensive. The point about the title to this session, Texas Electricity Grid Built for Efficiency, Not Resiliency. The point is our system is very efficient. We have very low costs, but the trade-off is resiliency. We don't have a bunch of idle generation sitting there just waiting for a bad day to start generating. Because if we did, we would be paying for it. As bill payers and and consumers of electricity in Texas, we would be paying for that idle capacity. And that is that's actually a technical distinction between many markets, is whether they have a capacity market or a real-time market, or if they're much more like Texas, where most transactions are private. So you can see, though, Florida and California much higher than where we are. And even the US average rate of commercial is is over 10 cents. If you go to the next slide, those are for commercial rates. We don't do residential, but we are very aware of residential rates, and we have some of the lowest residential rates in the country. My cousin in California, their home electric bill during peak pricing in the summertime, their rate is 29 cents a kilowatt hour. It's not even on this graph. Whereas you see in Texas on the far left, Dallas and Houston, we have some of the lowest power in the country, and you can see the US average there. If you go to the next slide. The other thing about Texas is it's highly competitive. We have 6 different regions. There's about 7 million deregulated meters, and there's over 60 competitors. What's interesting to point out about these different companies is they all sell exactly the same thing. It's an electron. It's exactly the same. Every electron is created perfectly equal. There's no Walmart brand electron, and there's no Gucci brand electron. They're all the same. So what's the difference in these providers? They sell the same thing. So much of that comes down to the next slide here, which is what does a rep do? So here's their role. They purchase wholesale from power generators. They resell that to the customer. They are responsible for the interactions. They do the billing and collecting for transmission and distribution. And they do the collecting for power purchase. And the distinction, the Public Utility Commission in the law, a retailer is not allowed to own generation. The reason is that's what Enron was doing in California, is they had retailers that owned generators. And so the retailers would signal to the generator to drop load, which drove up the retail price. So Texas learned from California and did not repeat the same mistake that California made when they deregulated and then ultimately re-regulated. So if you go to the next slide, this is where risk comes into view. This is a conversation about risk management. So you go out, you go to buy power, and somebody comes along and says, gosh, I'll give it to you for 2 cents. Well, that's hard not to jump on. Well, gosh, 2 cent power. My gosh, why wouldn't I do that? Well, there's a lot of reasons. First off, much like any transaction, who is selling this? And so when we evaluate retail electric providers, and these are the big bullets, I'll go into the nuanced bullets as well, but The first thing that we advise when we're working with a client to procure power on their behalf as a broker, we first look at the providers. What's their credit rating? How long have they been in business? Are they publicly traded? You know, can I research this company? Do they have declarations? How many customers do they have? Do they have a bunch of? What types of customers do they serve? How many utilities do they work in? What's the primary load served? Meaning, is it primarily commercial, industrial, or residential? Does the parent company own generation? Do they have things like a smart meter data and billing portal or customer service, right? So these are the big points to look at that derive the pricing. Because oftentimes what you'll have, you might have a new startup retailer that can secure a $100 million credit line, and then they can go out and they can sell power. But that doesn't mean that they know what they're doing. It doesn't mean that they have good credit. It doesn't mean that they are hedging appropriately. So it's important to understand that the customer is relying on the risk management strategy of the provider. If the provider is risky, so too is the contract and the rate. So if you go to the next slide, this is my warning to all buyers of power in Texas. Buyer beware. There are a lot of energy companies that go belly up when bad things happen in the market because they weren't properly hedged, or they got squeezed, or they weren't appropriately positioned. So one that got a lot of press was a company called Griddy. Griddy is an indexed product, and they actually applied to the Dallas 2030 district. We did not allow them to join because we didn't feel that representing indexed rates to our members was a good idea because of the inherent risk. And it turned out that they blew up about 4 months later. But they weren't the only ones. And Just Energy owns about 5 different retailers: Hudson, Tara, Amigo. So buyer beware. Don't listen to the salesman. Listen to your conscience. Look at the contract. Read the terms. If you go to the next slide. This is a personal article here. 2 men who saw the storm coming and sold their electric companies before disaster hit. Starting with the bottom highlights there, 2 former CEOs in Dallas saw this coming years ago, which is why they sold their companies. They'd separately come to the same conclusion. If something like last week occurred, it would put them out of business. And one of the CEOs believed disaster was likely. That company was Stream Energy and Ambit Energy. Stream began registering users in March of 2005. And it took only 10 months to become the 5th largest retail electricity provider in Texas. One of the first clients that I ever marketed for, newly in the business, I started in March of 2005, and Stream Energy was our client. We did marketing and customer acquisition directly on their behalf. And that 10 months to become the 5th largest retail electricity provider in Texas is one of the reasons that we were awarded shares in the company, was for that performance. So I know Rob Snyder, the CEO, and he is very much a visionary, and this was not a surprise. This was known, it was out there, it's just that we didn't do anything about it. So now we have an opportunity to prepare better for next time. If you go to the next slide. This is directly from our RFP. Now, this is not something that we do for all clients, but for large consumers, many of which are on this call, this is only about half of the retail provider qualifications that we look at. But I want to point out, we're happy to share these slides. Item D is really important. Evidence of financial capability to provide electricity service based on credit grade information, publicly available financial documents, and cross-referenced in the reps response package. G, description of wholesale purchasing and hedging practices and policies in a list of current wholesale providers. So this is basically speaking to, are they creditworthy? Are they institutional grade credit? Are they just brand new? And how do they hedge? So if you go to the next slide, I know I'm coming up on time, so I'm going to try to blow through some of these because these are important. You will not see very many products or services bought inside of a commercial property that have the volatility potential of the energy prices. Natural gas is the primary driver of electricity prices in Texas. If you look at the far left, you can see the scale, 0 to a high of 14. So imagine this was the cost of gasoline. And one day it was $2, and then a month later, a year later, it was up to $6, and then a few months later, it was up to $14 a gallon. Imagine you went from paying $2 to $4 a gallon, and then all of a sudden it was $14 a gallon. What would that do to your monthly budget? The same consideration applies to a commercial property. This is why it's a risk management conversation. When the market peaks again, what protection do you have in place to protect against the volatility? Do you have a fixed rate or an index rate? Is your fixed rate provided by an institutional grade customer or provider? If you go to the next slide, what kind of a product are you on? And this is that risk profile and product selection graphic. If you see to the far left, that represents a fixed rate, and the range of cost outcomes is very small because it's fixed. On the far side is a float or an index, meaning you are exposed to the full volatility of the market. So if prices run up to 14 bucks, what are you going to do? Can you afford that? If not, you definitely want to be on a fixed rate product. If you are a large manufacturer and you have an in-house energy manager and you're watching the real-time markets and you have a full-time hedging desk, well, then an index product makes sense for you. If you go to the next slide, what charges are fixed? This is in your contract, and to be sure, they will oftentimes break it out, but many providers will not. They just sort of bury it in there. But where it says fixed, all of those that are fixed can also be passed through. And so if you don't know what you're looking at and you have somebody come along and tell you, well, I'll give it to you for 3 cents, but all you're really getting is energy and they're passing through everything to you, that 3 cents looks attractive if you don't know that these other items can jump up to 3, 4, 5 times what they normally would be. If you go to the next slide, this is directly from our RFP. This is attachment B. I just wanted to use this to point out how many items there are in a price that you can negotiate. So the top section is the electricity supply and scheduling. You can see the items in there, and I won't bore you with trying to read this, but you'll see them there to be included in the price or treated as a pass-through. So the first 2 big sections are all included. You can see the items that we negotiate, and then bottom, the regulated TDSP charges, we don't include those. You can include those in your rate, but you'll pay a massive premium because you can't control those charges with hedging. It's whatever the utility tells you. But the other items, the quote, deregulated charges, you can negotiate. You can hedge those. You can buy those in advance and secure your rate so you don't have the issue. If you go to, I think that might be the last slide. Here you go. Building resiliency into your electricity sourcing strategy. So here's what's important for the takeaways from my portion of this presentation. You must understand the relationship between risk and price. The lower the price, the higher the risk. If you're looking at index rates, your price will be very low and your risk is going to be very high. The other element of risk is the retail electric provider credibility. Are you looking at an institutional grade provider, or is this, Tommy's power company that just started? Fixed rate versus an index rate, what's included, what's not, long-term versus short-term contract trade-offs, contract management, data and pricing transparency, and then comprehensive rate analysis. And so the idea behind this presentation was to present the digital side of the strategy, which is your contract and your commodities that you buy. And the part that I'm going to hand off to Tim is exciting because nothing is going to, go to the next slide. I'm sorry, there is one more. The chief task in life is simply this: identify and separate matters so that I can say clearly to myself which are externals and not under my control, and which have to do with the choices I can actually control. This is from ERCOT. They're telling you point blank in their publication. Generation owners and operators are not required to implement any minimum weatherization standard or perform exhaustive review of cold weather. No entity has rules to enforce compliance. The plans or weatherization standards. The only entity that can confirm that a plan is weatherized to any particular standard is the entity that owns or operates the plant. My segue here is that you cannot control the owner and operators of generation plants, but what you can influence, or if you're the owner control, is your building, your property. What can you do to winterize your property to prepare for the next winter storm? And so this is where I'm going to hand it over to my friend and colleague, Tim Thiel, and let him take it from here. Thank you.
Thank you so much, Jacob, for giving us such a great background on Texas and electricity. For those of you who just joined us, I want to introduce Tim Thiel. He is from Covestro. He sits on the 2030 District Network Board, and he also sponsored this event. And I'm going to let him get started on his part of this session, which is how can we better prepare for the future.
All right, thank you, everyone. And you can go to the next slide. Okay, we all read that for my lawyer, so we can go to the next one. Yeah, and I just want to give a little bit of background on our company. As Salima said, we've been involved with multiple districts. I've been on the board for years now. We're a large material sciences company. I am in Pittsburgh, Pennsylvania. The company's headquartered there, but we're a German company as well. We do material sciences, so think BASF or Dow. We used to be part of Bayer, like Bayer Aspirin, BAYER, and they spun us off about 5 years ago now. You can go to the next one. Oh. Yeah, just real quick so you know where I'm coming from. I've kind of worked in this area of building construction and the building envelope for almost 9 years now. Across our various units. I'm not going to go through all of these, but we do products for insulation. We do products for adhesives and sealants and coatings for buildings. We do daylighting. So we kind of cross the gamut of all the areas of the building, and that's kind of what I'm going to talk to today. Use a lot of pictures, a lot less words and data than Jacob, so it'll be a little bit different, but I'd like to walk through that now. You can go ahead. So really, I like this quote, the future never just happened, it was created. And really, we have a hand in our future. And I think Jacob mentioned it, we have to be ready. The title and some of the key things we sent around on passive design and then things that we can influence. We can't influence really the grid going down, like we talked about. We can influence, though, how our own structures, houses, or commercial buildings, react to items that happen like that. I like this quote, and for those of you who don't know, the Durants are authors. They wrote a large story of civilization volume. It was 11 books and about 10,000 pages, millions of words. So I like their quote, and also they were resilient. They wrote it from 1935 to 1975, so that's fairly resilient work there. Next one, please. Next. So just some basics here. I wanted to show you, as Jacob talked about, there's some simple things to look at in your buildings and some rather inexpensive things to look at, but just real basic. I mean, we think of our buildings and your home or your commercial building, you work in your own. It's really just a big box of air, right? We use mechanicals to control this. We also really need to think about the building envelope in this case. Often we focus too much on mechanicals. I'm not saying they're important, but if you put the best mechanicals in that you can possibly get, Energy Star rated, HVAC, and the best lighting or whatever, if you have a bad envelope, it's really not going to do much, to be honest. We often talk about, in my line of work, what we call integrated design, meaning that, if I switch my air conditioner, I might get a 10% energy savings. If I then switch my air conditioner plus do windows plus seal them, I might then jump up to 25%. So the sum of the parts is going to be better than just doing one. So often we talk about the integrated design. And I'll also make a comment, really, I did solar on my own home, and some of the first questions they'll ask you, commercial or residential, is, did you do all these other laundry list of items? I got brand new windows. I got a new air conditioner first. I'm 100% LED. Then I decided to do solar. So to me, you have to do all these other things that will integrate well with that solar system, or you're honestly you need to passively save the energy first. But really the key on this slide, air leakage, and I'm going to talk about it. But really, if you reduce your air leakage, you're going to reduce your energy consumption. You can see the figures here from NIST coming out of the government agency. Next one, please. This is a simple, I guess, simple diagram created by Joe Stiebrick. If anyone follows building science, he's one of the preeminent kind of building scientists. He's been around for a good bit. I think I met him 20 years ago, to be honest. He talks about diffusion a lot. Just water diffusion going through a gypsum board, typically in a normal heating season. So when your average temps below 65, you have 1/3 of a quart of water going through there. If you go to the next one, this really shows you the importance of the envelope. For those of you who don't know, 3/4 of an inch is the same size as a penny. I actually looked this up to have something relatable. If you punch a hole through that same gypsum, basically you're going to get 25 quarts of water in the same heating season. That's 75 times the amount without that hole. And what happens here then, you have this leak that you might or might not know of in your building, shell and core, whether it's commercial or residential, and those same mechanicals are going to work harder, right? So in the summer, they're going to work harder to basically get the humidity out of that space. Some of the things I talk about, often is there's a test called blower door testing, which you can get done in residential or commercial. I know for the residential side in Texas, you can have a HERS rater come and do this. I believe for commercial HVAC will do this test for you. I know Green Building Advisors has a website where I believe you can find a blower door test application specialist. And what this is, for those of you that don't know, they basically pressurize your building. They have it sealed in a certain way. They literally put a large type blower or fan in different parts, and it's looking for leaks. They send a non-toxic, obviously, smoke kind of throughout your building, and it's going to find a hole like we see here, the size of the penny. Then you'll know exactly where you need to look at your envelope and kind of do, I would call it an easy, probably fairly cheap renovation or retrofit or resealing of your envelope. Next one, please. Salima and Jacob and I talked about this weeks ago, and I really just wanted to show a couple items and kind of tell a couple stories here. These are cheap. If you look on here, these are all items that are very cheap. I've talked to actually Pittsburgh 2030 before on some of these items. And, if you have a commercial building with a revolving door, change the sweeps on it, the top left. Super cheap, change it. I know here we have more problems with salt and things kind of degrading our seals and stripping and stuff like that. You guys don't, but these things fall apart. And these are just so easy of items to fix. My own home, I do my garage door, the gasketing every couple of years, because frankly, it dry rots. You can do the window pilings on the bottom left fairly easily. And then over on the right, these are kind of gap filling products. We've all seen like cans of foam or other type gap filling products and sealants. One story I like to talk about, I worked and lived in Georgia, so south of Atlanta, and summer that I went there, I think it was the drought. It was 2007. And our facility there, you're talking 90 days in a row above 90 degrees, above 90% humidity. And I was probably 150 yards away from our loading dock doors. And in the office, in air conditioning, I can automatically tell when those doors were open, right? So, these are all things, I think, in these commercial buildings that we can look at easy, items to look at. What we ended up doing, obviously, when they're closed, it was a little better, but we put new gasketing around the closed doors. Some of those solutions on the site we did, on the slide, And then really we put in, and I'm not 100% what you call it, but it's the same, it's large, like plastic or TPU type strips that are probably about 1/2 foot wide that hung from the top of the door down. When the truck would pull in, it would back through and they would obviously push open. But they kept the air from going around the entire building. In the winters, the same thing. We felt the cold coming. And again, we're talking hundreds of yards away. So, like I said, simple items that we probably don't always think of can go a long way. Next one, please. Sorry, next one. I like to use this example. This is obviously a residential garage door, but really the key for a building to me is the further away from conditioned space you actually extend your building envelope, the better off you're going to be. Again, it'll keep your building at a temperature that you would like in the winter and or summer. It keeps your mechanicals from working as much, which then is going to drop your energy consumption on the building or your home. This is a photo one of our guys took at a job out in Reno, Nevada, and you could really see with an infrared gun, you're talking a door temp of 145. The garage was up to 90. Middle of the day, it got up over 100. People often have garages that have refrigerators or freezers in them. When you have a situation like this, they're going to work harder. People also typically have living spaces above their garage, so you could feel the heat coming up through the actual floor of your living space. I actually have this. I mean, it's not as hot in Pittsburgh, but my next project might be insulating the actual ceiling of my attic, which is really the floor of my family room. So that would help. Again, you're pushing kind of your core and shell further away from your living space, which again is going to help with the mechanicals and your energy consumption. Next one, please. A little bit about roofing, and I'm not a building scientist and I'm not a roofer, but I think I know enough to be dangerous here. This is your typical single ply roof. For those that don't know, typically you'll have a movement towards cold air. So in the summer, the heat wants to go from your roof deck into your air conditioned space. In the winter, your heat wants to leave your conditioned space and go outside to the cold. If you look here, all the red kind of pin looking things are fasteners. They quickly become thermal shorts, or kind of like a thermal bridge or a thermal highway, I would call it. As the roof heats up, energy goes through those and goes down into your space. In this summer, it's seeking out your air conditioning. In the winter, it goes out and it's seeking out the cold air. So, I mean, there's some things here you can do. This one is probably under insulated. The other thing we talk about, you can have a monolithic roof insulation, some sort of spray insulation where there's really no attachments. You can get a self-adhered membrane, which there's no attachments. And again, some of these are more expensive than your basic TPO or EPDM roof that might be attached like we see here. But one of the other things we talk about is, and I know Jacob has talked a little bit about R value in his own home. If you're looking for a certain R value in your roof, thicker insulation boards, no matter what you use, if it's polyurethane or polystyrenes or mineral wool, whatever you choose, I mean, thicker isn't always the best. You're better off layering it. If you layer insulation boards and then tape the seams, you can attach the lower insulation boards with fasteners, and then the top one, the key is adhere it down with some sort of adhesive, and then you do not have these thermal shorts, and you won't have basically thermal bridging occurring between your conditioned space and your roof. Next one, please. This is actually a really good example of thermal shorting or thermal bridging. So this roof here was single ply. We had someone on this job. We were actually going to spray foam this roof after, tear off this roof and put a new one on. But basically you could tell the final layer of insulation and or the membrane was absolutely mechanically fastened here. Obviously the venting, you're going to have some melting around that large vent there. But if you look, you can see every single attachment head on this roof for 20, 30 yards each way. That's energy. I mean, that's energy you're paying for. It's energy that's leaving the structure. This doesn't have to happen, I guess, is the real story here. I know commercial roofing, you typically get 20 to 30 years. So really when you go to do your re-roofing, I mean, these are things you want to ask about. If you use a architect, you would ask about this too, how to prevent thermal bridging, how to not use attachments, I think are really important questions here. Next one, please. We did this as kind of an example. Someone in our company did 3/4 of this roof with high performance insulation, and we left that left corner there uninsulated just to show you. Basically what I tell people, if your commercial building looks like the one on the left or your house does, and your neighboring building or neighboring house looks like the right, then you know you have some kind of problem. You have air coming through and melting the snow. The heat's running to the cold, like I talked about, somehow thermal bridging, or you have some kind of leak. And I mean, this is really a dramatic example, but even if you see a 4x4 spot like this or something similar, there's obviously something you would need to look at. Again, that blower door test would find if you have a puncture. Frankly, it could be that your roof just very under insulated compared to your neighboring commercial building in this instance. Next one. When we look at this, I mean, this is somewhat disturbing for someone like me. I have pretty bad allergies and asthma, but we've opened wall cavities like this, and this is what you see. And not that the insulation type here is bad or good. There's differing insulations here. I think the one on the left's fiberglass, the one on the right, one might be mineral wool. But obviously there was some sort of permeation going on here. Most people, you wouldn't know this. I know a lot of people that fall ill sometimes, it ends up coming back to there's something in their structure. So we talk about healthy, buildings for commercial and healthy buildings to live in. I mean, I think this is one thing to really look at. There's two schools of thoughts on kind of your building envelope. And as Jacob did, I'll give my opinion, there's permeable versus impermeable. It really all depends on how you seal it and, the types of insulation and types of cladding. My opinion, and I'm more of a proponent of impermeable, meaning water, air, and everything can't move between it. There is a school of thought that some people like permeable because they feel like if you do get moisture, then air will dry it out. I mean, there's studies on both. So, I mean, I would just be well versed when you're picking an envelope, wall insulation, roof insulation for your building on the science behind both of them. I think there's pluses and minuses of both. Next one, please. All right. So we had talked about really choices matter. I don't want to go into all of these. This is something we had done for, honestly, a trade show a few years ago. Not being brand or technology specific whatsoever, going through some of these categories, it's really just to show you that products are resilient, right? And product choices create resiliency. So any kind of fenestration sealant, doors and windows, any access point to your building. I know there's fire hatches, even skylights. These products are there for a reason. It's ingress of water and air. The benefit really is it allows everything to last longer, but really it's items I think you should rethink about and look at every so many years. I mean, there's some good caulks and sealants out there, but really if they're not applied 100% perfect, if you get an air bubble, or something like that, they'll start to fail at some point. So these are fairly cheap things that you're probably own maintenance people for commercial buildings, and in your own home you could do yourself. I resealed a lot of my windows before buying new ones myself, and I'm not super handy. Reflective roof coatings to me are a good idea in your climate. Up here in Pennsylvania, white roof coatings don't make as much sense because our cooling season's much shorter. So most of our roofs are black to absorb sun and thermal heat for the winter. But really any sort of roof coating, it helps resist punctures and leaks. It helps do what I was showing, keep out the moisture, keep out the air from moving back and forth kind of in a highway. Protective glazings. I mean, there's glazings for wind impact, projectile resistance. I mean, the better kind of windows and doors you get, I think the better off you are. The one example I give a lot is, if you have metal windows or like a metal door, put your hand on it. You can typically feel it being hot or cold. That's energy. That's, again, your mechanicals are going to run more. Excuse me. They make a lot of window products now and glazing products for commercial facades and residential that are really more of a composite material. You have some plastics, you have composite urethanes, you have thermoplastics, you really have the gamut. They also make metal windows that would have what I would call a thermal bridge insert that'll keep that from happening. So, or even just an insulated window frame. High performance insulations, we talked about enough already. Insulated metal panels, an interesting retrofit project. you can take basically a brick or masonry or any type of building you have and reclad it. We did it here on our campus in Pittsburgh. We use polyurethane metal panels because that's the space we work in. But I mean, they make polystyrene ones, they make mineral ones, and really it's a fairly good way to renovate a building. We took a 1960s really nut insulated building and reclad the entire thing right over kind of old school brick. So our building looks newer. The R value is way up. It's an impermeable envelope, and we really reduced our energy costs and sealed the envelope. I mean, the only kind of thing here is you have to like the aesthetics of it because you're completely changing your building. Spray foams I talked about, and the composite for doors and windows I also hit already. So next one, which I think might be my last couple. This is from buildinggreen.com. There's a very, very good kind of resilient checklist out there. I pulled just a few off, and I do not want to go through all these. I think the presentation will be available, but you can go to their website and look for resilient checklist. But I mean, some of this honestly is kind of common sense and no brainers, but frankly, I wouldn't think about it. Elevating electrical, mechanical equipment, especially in basements and things like that. Specify materials that if they get wet, they dry. So maybe you're not into that mold and mildew type situation. There's different drywall types made for wet conditions. So I know I use different drywall in my basement compared to the rest of my house. The insulation, you can look, there's climate zone recommendations out there from various organizations. Really optimize your building for solar gain in the winter. And these are things you really can't do to your current, but building orientation is very important. Face them on east-west axis, so glazing area is greater on the south for direct gain and passive solar heating. Natural cooling, if you guys had the issue in the summer that you had here in the winter in February, you would want to have operable windows so you have breeze channeling. Maximizing daylight is also important. Just one, so you don't need lighting to keep your energy on, and two, if your power is out, you could pretty much go about your day in your commercial structure and still see and work. Backup energy systems. We talked about the grid a lot. I know wood and pellet stoves, solar water heaters, things like that. And then plan for shortages. I do find it interesting that people tend to do this after the disaster. And I think the whole idea of today with Jacob and I, as you do it before, in Pennsylvania, if we have a bad snowstorm and the power's out, every single person's trying to get a Walmart to buy a generator, things like that. So, I mean, the more you can do ahead of time passively in your building to be kind of prepared for the next time something happens, I think the better you are. And then the final slide is really just something I thought might be interesting. We have a global wind group. And really, I think there's going to be a change of focus here after what happened in Texas. We work on systems for the cabling for offshore to protect the offshore wind. We work on systems for the composite blades. We work on coatings for abrasion resistance and tearing and basically longevity and efficiency of the spin. I think now we're probably going to start looking into a little bit on the idea of, could there be a coating that helps with ice? So I know some people have de-icing in different states on wind blades. I don't believe Texas has it. I know Iowa has it on their wind farms. But I mean, as a material science company, we'll see something happen like what happened to you all in Texas. And we'll go out and say, okay, can we make some sort of solution that could prevent those from freezing at a certain temperature, could prevent ice buildup from basically, for lack of a better term, sliding off. So I mean, these are all things like we'll look at now that frankly something happened. But that is what I had today. And I thank everyone. And we would appreciate questions if you have any.
Well, thank you so much, Tim and Jacob, for all this great information. And we appreciate you taking the time and talking to us about it. I also want to, before we get to questions, is thank Dan from FSG. He's our founding member also, and he was helping me with monitoring the chats and the logistics of this session. So I wanted to thank all three of you for all your help for this session. Dan, are there any questions or thoughts in the chat that we need to address?
Well, there's one question from James Ornstein. It's I don't know if you want to bring it up. It says complicated question for follow-up offline. Any comments on the implications for Dallas building construction if Dallas County is moved to a different climate zone or status of this change? The 2021 IECC code apparently splits the DFW Metroplex, but I've also heard that the 2024 IECC may change this somehow. And he's got a link there as well. We probably want to move that question, give that to our two speakers and have them reach out to James separately. I'm not aware of this issue myself.
Yeah, Dan, I think that's a great idea. We can address it. It's a little complicated, but we can address it outside of the session. Thank you.
We can talk about building codes a little bit though, which I think is what that sort of one of the core elements there is. Do building codes drive resiliency? And this is an opinion, but building codes are sort of the minimum standard. You know, they're not designed for sub-zero temperatures for prolonged periods. They're made for safety. They're made for other, codes are there for different reasons. But how we are impacted by the different climate zones, I'm sure would have an impact on building codes. But really, the resiliency factor is to make up for what the generators aren't doing. The power generators are not going to winterize their systems until they're forced to. Salim actually sent me an article just the other day talking about that the Texas legislature was meeting again on this topic as emergency session. And what came out of it was that they're making recommendations, but it's the same recommendations from 2011 that weren't implemented. And so here we are again. It's the same thing that happened 10 years ago. Here we are again. So codes really aren't going to save or protect us. Codes are for different reasons. This is really more about preparing for these weather events that are occurring more frequently, but are also not addressed through code. They're addressed through competency and awareness of what's actually your building is prepared for. That's what I would say there.
And I mean, just to echo that, I mean, codes, again, are a minimum. We would always, as a company, advocate for overcode, to be honest, especially on core and shell. And then two, even the current codes a state adopts, they're typically years and years behind, and they're already working on the next code cycle. These things take a minimum 4 years usually to get through. I mean, there might be some states still on like 2012 right now, and they're working on moving up to like 2018 or whatever. So, I mean, it takes years. So the code somewhat becomes outdated by the time it's implemented. So, and now, I mean, there is some good one. There's like passive building codes and some of the higher energy efficiency ones. I would say they're good to look at. But in general, the codes and regulations from state or recommendations from federal are kind of bare minimum, I would say.
Great. What I will do is I've actually copied that comment from James, and I'll send it to both of you and copy you as well, James and Salima.
Perfect. Thank you so much, Dan.
Thanks, Dan.
That's the only comments we have so far.